I am Clelia Crialesi. I am a Marie Curie postdoctoral fellow in Paris, working at the CNRS laboratories there. I work on medieval philosophy of mathematics and history of medieval mathematics, and I'm happy to be with the IPM Monthly crew today.
Welcome, Clelia. First of all, thank you so much for doing this interview. And to start, I am going to ask you, could you briefly introduce your current research focus and how your Marie Curie-funded project MUCH aligns with your broader scholarly interests?
Sure. Thank you for having me. My Marie Curie project, that is MUCH, titled MUCH as an acronym, tries to put together the history of philosophy and the history of mathematics. And more specifically, what I try to do is to put together, or better, I try to frame the history of medieval philosophy, the history of medieval mathematics, within the history of medieval philosophy. How do I do that? For instance, I focus on the way algebraic practices intertwined with philosophical questions, such as how do we conceive of a quantity that is neither discrete or continuous, and that seems to be totally detached from any physical instantiations, and which are our epistemic strategies to cope with this sort of mathematical quantity. And I guess that philosophers and theologians from the 14th century came up with two useful tools, one epistemological and the other logical. So on the one hand, if we want to make sense of that sort of mathematical quantity, we can, for instance, target and study the abstraction process that we put forth when trying to grasp mathematical items. And on the other hand, for instance, we can identify the logic procedures that help us to isolate the properties, including mathematical properties, in the objects we are dealing with. And they call this specific procedure reduplication. One of these procedures is reduplication, so basically the exploitation of the qua operator. Since my PhD studies, and actually since my MA studies, I was very much fascinated and intrigued by the different manifestations of mathematical thought. For instance, I started with studying the early medieval Neo-Pythagoreanism and the early medieval speculative and practical arithmetic. Then I moved to the way geometry made its way into debates on natural philosophy and so on and so forth. So that's really, I would say that generally speaking, I'm really into the epistemological, ontological, and metaphysical implications of mathematics.
So MUCH explores the intersection of philosophical reflections and mathematical practices, as you said, but in the 14th century Italy. What inspired you to focus on this period and its unique educational landscape?
Yeah, that's a very good question. I will answer by recalling first an extraordinary figure in the history of philosophy and science, which is Luca Pacioli, a 15th century polymath. For those of us, who are not familiar with this character, I just say that he was at the crossroad of different learning institutions. So basically it was at the crossroad of the university, the city schools of mathematics, and the convent, since he was a Franciscan friars. So he wrote of mathematics, theology, physics, and so on and so forth. So he was really an extraordinary figure in the history of mathematics and philosophy. But we usually look up to such figures and don't realize that most of the times the conditions that led to the existence of such figures, of such characters in the history of science as philosophy, were already in order, were already there. And this is the case with the 14th century Italy, which makes an exquisite and unique case study if we want to tackle the interaction of mathematics and philosophy. Because back then, that is in the 14th century, Italy witnessed a unique intellectual and cultural context that was basically characterized by the interaction of social actors, social and historical actors, inhabiting different learning institutions. So we have university masters, university professors, abacus masters, and theologians. So basically the learning institutions that come together are the universities, the abacus schools, and the convents or the studia of mendicant orders. Abacus schools are basically the city schools, so most of the times they are public schools, meant to educate the offsprings of the newly born social class of merchants, educate in practical mathematics, practical arithmetic. And it's very interesting to see how different actors inhabiting different institutions interact among each other and thus cross-pollinate their own ideas among different contexts. And this is exactly what I try to show also in Match.
Perfect. So you have a forthcoming book, right? It's called Mathematics and Philosophy at the Turn of the First Millennium, Abbo of Fleury on Calculus.
Yes.
And it promises to uncover the interplay between arithmetic and broader philosophical theological systems. What drew you to Abbo's work and why is it relevant today?
Okay. Yes. How can I put it? Let's say, so I got interested in Abbo's thought while completing my MA studies. So I was writing my MA final paper, and while browsing the literature, I bumped into Abbo's name, and I was working back then on the 12th century school of Chartres. So I bumped into Abbo's name, and I was quite curious about his personality, his thought. Especially because I kind of saw a sort of lineage from his thought up to the school of Chartres. And so I decided to look more carefully into his thought, and I decided to do my PhD exactly on his mathematical work. And by mathematical work, I mean an arithmetical treatise. Now, this arithmetical treatise is basically a commentary on a series of multiplication tables written and put together in the 5th century by Victorius of Aquitaine. So Abbo is basically commenting on tables, mathematical tables, multiplication tables. And the question that really led my inquiry was, how come we can make philosophy out of such a sterile topic? How can we make philosophy out of mathematics? Broadly speaking, how come we so tightly relate arithmetic to philosophy? And Abbo is a master in answering these questions, these sort of questions, because he is really able to tie together the way we conceive of the created reality. Of course, according to him, we live in a created world, and the divine principle that managed to create reality. I believe this sort of research and forthcoming book, of course, are relevant to the scholarly community, mainly because they help us dismantle the belief that philosophy and science were quite dormant in the early Middle Ages, and more specifically in the 10th century, the darkest of the Dark Ages. So yeah, this is my contribution to illuminate that kind of that period of time.
Perfect. So the book emphasizes henology and the theory of composition, right? Could you explain how these concepts inform Abbo's understanding of mathematics and its relationship to reality?
Sure. So unity and compositions are like the essential binomial of Abbo's thought. And consequently, they are the notions that serve as a compass also to browse, to navigate my own book. So on the one hand, we have a theory of unity that is fit to describe both God and creatures. Now, of course, the unity as applied to God is actually different from the unity applied to creatures, because God's unity is absolutely simple and undivided, whereas the unity that we apply, that Abbo applies to creatures, is a fragmented unity, or at least a unity that can be always divided. So this fragmented unity, while describing the creatures, makes the object, makes the subject matter of mathematics, and more specifically the calculus, which is basically practical arithmetic, making use also of fractions. So on the one hand, we have this theory of unity, and on the other hand, we have the notion of divisibility and composition. There are really features of created beings. These are essential features of created beings, both visible and invisible. So these kind of features apply to horses and as well as to, measures of time and human voices, which are invisible things, but yet are divisible because precisely they are created. So these are the main notions involved in Abbo's thought.
So I want to move on to your career. As a historian of premodern philosophy and mathematics, what do you see as most pressing challenges or opportunities in your field today?
I would say that the challenges that are proper to people working in my field apply to everyone working in research in general. So I'm not trying to make it a quarrelsome. What I'm trying to say is that the main challenge for people doing this sort of research is basically that of securing a permanent position, or at least that of securing research fundings. What does it mean? Well, it means basically that if we want to get research funding, we have to make proposals, and we have to make our research projects attractive to evaluators or to people that really evaluate our proposals. So at the same time, to make, and this perhaps might be something that we are not really used to, we are not really trained for. So there's already that challenge. But there's another challenge, definitely more important than these, which is the challenge of making sense of our own research. The challenge of how we make our research meaningful to today's society. So basically, perhaps it's a bit too abstract, but I perceive this as the big challenge we face today, the big challenge researchers face today, researchers in our field, of course. So how to account for our job in society.
And finally, do you have any advice for aspiring scholars interested in exploring philosophy, mathematics, history? What would you say to them?
Well, I guess I'll be very brief on this because I don't have any definitive advice. But perhaps what I can say is that If you happen to do an interdisciplinary research, you might want to approach your topic in a truly interdisciplinary way, so in a comprehensive way. So if you happen to be interested in the history of medieval philosophy of mathematics, don't be scared, don't be afraid to tackle also the medieval mathematics of the time, also because most of the time the medieval mathematics is not that hard to understand. So go for it. Don't be scared don't be scared of delving into technical stuff.
Thanks so much.
Thank you.